In today's class, we are going to discuss the next algorithm called as gradient boost. Gradient boost. Again, once again, I'm saying, if you understand this one, today's class, tomorrow's class is extreme. Extreme gradient boost. Means I have to explain only the word of extreme. Concept, everything remains same. Right? So yesterday, I have taken one data set of like this original Y and predicted Y. And I told you that decision tree number 1 is going to predict the answers. And for the decision tree 1, whatever the initial weights are there, and the second decision tree is going to have like this. And many of them are still not able to understand that how the second decision tree will form. Means decision trees also they want to see visually, completely. So for that reason, today I have taken one more data set. From the starting to ending, complete whatever we are going to write in the things. Okay, detailed explanation is there. Step-by-step explanation with the values also. Directly the mathematical values are also inside the PPT only. You don't need to write any of the notes. Whatever the running notes is there, that running notes also was there in the PPT only. Right? Just focus on step by step. Okay, clearly focus. Every slide you focus, and any slide if you are getting error, if you're not getting understanding that particular concept, immediately raise the hand. So that I can explain the same slide once again. Then I can move on to the further. Now gradient boost. Whatever the gradient boost is there. So in addition with gradient boost is used for the classification. There is a lot of common things in the logistic regression. Again, I'm going to use the logistic regression where logit function is there. That logit function, using that logit function they have created. That is e to the power of y divided by 1 plus e to the power of y. That is logit function, which is nothing but sigmoid function. Sigmoid function in order to calculate the probability. Right? Now we are going to use the same thing here. Now what is this y value? In the logistic regression, y value is nothing but beta naught plus beta 1x. It is working on the linear regression. So by using the linear regression, first we are calculating the y hat, and this y hat we are using and predicting the p hat, that is e to the power of y divided by 1 plus e to the power of y. Right? This is logistic regression. Now the same thing we are going to do in this one. Here the y is different. There the y is beta naught plus beta 1x. And after that, you are going to use the p value. That is e to the power of y divided by 1 plus e to the power of y. Here the y is different one. Here the y is log of odds. Log of odds is the y. Now what is meant by log of odds? That we are going to see. So y is nothing but log of odds, and p is calculated based on the e to the power of log of odds divided by 1 plus e to the power of log of odds. That is the sigmoid function is common. Only the difference is y. Instead of applying the linear regression y, we are going to apply the y is equal to log of odds. Now, what is meant by log of odds? All these things we are going to understand step by step. Right? Now, so here there is a small data set I have selected where there is 3 variables are there. x1, x2, x3, and this is the output variable y. So, x1 is whether the person will like the popcorn or not, yes or no. Second one is what is the age of the person. Third one is what is the person's favorite color. And fourth one is whether the person will love the Troll 2 movie name. Movie name is Troll 2, whether he loves that movie or not, yes or no. Okay. Now this is x1, x2, x3 and y. Now there is a person who likes the popcorn. Yes. Age is 25. His favorite color is blue color. Whether this person will buy interested in this movie or not. We have to decide based on these input features. Don't ask the question, sir, generally movie will be decided based on the cinema story. Now this is not there. There is no story, there is no hero, there is no heroine. Just only the data. Based on the input data, we have to predict the output data. We have to identify the relation between input and output. If there is a relation, means identify. Sir, both are not related, means we can't identify. Simple. Now, here I'm going to use a small training data set. For this training data set, where I'm having 6 records based on whether the person will like the popcorn or not, what is their age, their favorite color, and whether they love the movie, Troll 2 movie or not. This is the small data set of 6 records. Right? Now, we are going to move on to the step by step. When these 6 records are given, these 6 records are X train, these 6 records are Y train. When I fit on the gradient boost dot fit on X train, Y train, what happens in the back end for these 6 records that we are seeing now. Is that clear? These 6 records are X train. These 6 records are Y train. And you are going to fit on the X train, Y train. When you execute this line of code, what happens for this particular data? Now, this we are going to see. Only this line I am going to explain. Remaining data cleaning is common, data wrangling is common, train test split is common, after hyperparameters is common, after that rebuild the model is common, everything is common. For this line, what is the meaning? Okay, that is the theory part, right? Now, here we are going to understand this gradient boost is also a assemble algorithm. Assemble algorithm where it is a boosting technique. Boosting means once again it is a sequential learning. Sequential learning means we have to combine the multiple decision trees at a time. They are not independent to each other. They are combination. They are combined. 1 and 2 and 3 and 4 are combined. And what is the difference between bagging versus boosting means? Out of which the first one is bagging is a parallel learning, whereas this one is a sequential learning. What is the meaning of sequential learning? Sequence means 1 by 1. And that too, they are dependent on each other. That too, we have to add everything. They are not separated. We have to add everything. So, everyone knows Iron Man, Avengers, Iron Man separately, superhero. This is a single model. Thor is a superhero, separate. Hulk is a superhero. Captain America is a superhero. But individually, everyone are very good. We have seen separate series also for that. Now, but in the end game, Avengers Endgame, that is last series, these individual superheroes are not sufficient. Now everyone has combined. They have combined. Initially they are strong only. But for that particular data, for that particular villain, whoever is there in the movie, for that particular person, these people are not sufficient. Now for this data, we have to combine all of them. And along with that, remaining part also, entire Avengers series, everyone will come into picture. That is at the end, we have seen, right? Now they have combined everything. Combinedly, now the power has increased. Earlier they are having individually superpowers, but overall when they have combined, their overall total power has increased, and which has helped to win that one, right? Over the villain, whatever he is, right? Now this one, whatever the concept is there, this is called as boosting concept. Okay, director has not copied from here. From there only we are copying. Okay, so now this whatever the boosting technique is there, combining all the weak learners, individually weak learner. They're weaker. Iron Man is weaker. Individually Iron Man is strong only, but for that particular data set, it is weak. Thor is individually great, but in that end game, what happened at the end? That particular he is not sufficient, right? That for that opposite person, he is not sufficient. Similarly, Hulk, individually he is great. Other movies he is great. There the villains are very weak. But in the end game, the villain is very strong. Data set to data set, it varies. All the data sets are not same. All the villains are not same. Right? Now, here just we are going to combine them. We are going to combine them in order to make the super one. All the weak learners are combined in order to make the strong learner. Right? That is boosting technique, basically. They are not fighting individually. Separately, they are not fighting. They are combining together. They are having a strategy together, and finally, they are working. Similarly, here also the same. We have to combine everything. Okay, not individually. Combine everything. Now, how we are going to work? For this data set, how we are going to work means, first, here also the same thing. Every decision tree is a weak learner. We have to combine all the decision trees. Next, this every decision tree, whatever the weak learner is there, every decision tree is pruned. They are not fully grown. Pruned. In ADA Boost, it is pruned up to depth of 1. Here, the pruning is done by considering the maximum leaf nodes. For pruning, different options are there, right? Out of which one of them is depth. Second option is maximum number of leaf nodes is one more option. In this case, we are going to use maximum leaf nodes from 8 to 32. This is the max. 32 is the max. We can't cross more than 32. Exact number, hyperparameter tuning you have to apply. Either you can go from 8 to 32. The maximum is 32. You can't go more than 32 leaf nodes. If the tree is growing more than 32 leaf nodes, means you have to cut the tree. You have to cut the tree in such a way the maximum number of leaf nodes is equal to 32. Okay. So you have to cut the tree in order to get the maximum number of leaf nodes 32. If you want to understand this concept, first you have to learn the decision tree. Without learning the decision tree, how you can understand what is meant by leaf nodes? And what is the use of maximum leaf nodes and what is meant by pruning? None of them you can understand, right? If you understand the decision tree clearly, now automatically you'll understand now what is meant by maximum number of leaf nodes. Maximum number of leaf nodes is one of the options for pruning the tree, means cutting the tree. When the tree grows, when the tree completely grows, if the tree grows completely more than leaf nodes of 32, in that case, we are going to do the pruning. If it is not growing more than 32, it has stopped in 16 only, then what is the use for you? No need to disturb that one. If the tree is growing more than 32, then you have to do the pruning. If tree is not growing more than 32, means don't disturb that tree. Leave as it is. That is with respect to gradient boost. Within the gradient boost, each decision tree was pruned up to a maximum depth of 32. Sorry, maximum leaf nodes of 32. Right? Now, so let us start how the gradient boost works. Means first we have to take the first one single node. This is the first node. This node is the predicted value. We are assuming this is the answer only directly. How this answer is calculated means the answer is log of odds. This is your initial prediction. The output you are predicting as log of odds. What is meant by log of odds means your log of odds are calculated based on number of people interested in the movie divided by number of people not interested in the movie is called as log of odds. Log of yes divided by number of no's. This is called as log of odds. Okay. Now log of odds is equal to 0.7. Actually, it is not 0.7, which is 0.667 something, and we are taking as 0.7. This is your initial prediction. You are predicting for every data point, 0.7 is the answer. This is your initial prediction. Y hat. Directly you are predicting as, that is P hat. Now, based on the P hat, now what we are going to do? If value is greater than 1, it is considered as, value is greater than 0.5, it is considered as class 1. If value is less than 0.5, it is considered as class 0. So this is 1, this is 1, this is 1, this is 1, 1, 1. Means everything you have predicted as 1. By default, first prediction is 1. Original data is having, original Y is having is 1, 1, 0, 0, 1, 1. Predicted Y is having this one. Now you are going to calculate the residual. What is the residual? The difference between these two, which is nothing but error, Y minus Y hat. Now 1 minus 1, 0, 1 minus 1, 0, 0 minus 1, minus 0.3, 0 minus 0.7, minus 0.3, 1 minus, 1 minus 0.7, 1 minus 0.7, which is 0.3, 1 minus 0.7, 0.3, 0 minus 0.7, minus 0.3, 0 minus 0.7, minus 0.3, 1 minus 0.7, 0.7. Okay, sorry, 0.7. Okay, 1 minus 0.7, again 0.3. Okay, this is your residual values. Okay, this is the original value and this is the residual values. So the same thing I'm calculating here. Just can you see how we are going to do the classification? Means by applying the logistic function, that is 1 e to the power of log of odds divided by 1 plus e to the power of log of odds. Just you substitute the e to the power of log of odds. What is the e to the power of log of odds? 0.7. Substitute here, which is nothing but, again you have got answer as 0.7 only. Now this 0.7 is your initial prediction. For this initial prediction, whatever the initial prediction you have got, this you are going to use and you are going to separate 1 minus 0.7 original values. Wherever the S is there, I'm considering as 1. Wherever the no is there, I'm considering as 0. Now using these values, first record. that is observed original value, that is 1 minus predicted value. What is the predicted value? 0.7. 1 minus 0.7, 0.3. Second one, 1 minus 0.7, again 0.3. 0.7 minus 0.7. 0 minus 0.7 minus 0.7. 1 minus 0.7, 0.3. 1 minus 0.7, 0.3. This is the residuals. Now actual gradient boost starts. Now you understand clearly. Generally, decision tree, how we have to form the decision tree generally? By considering the input variables and output variable. Here, we are going to form the decision tree based on the input variable versus the residual. We are going to form the decision tree based on the input variable versus residual. So see, I'm going to form the decision tree between based on the input variable versus residuals. This is the tree. If you want, you can check. So first I have taken the color is equal to red. Means I have started this one as the initial one, root node. Wherever the answer is equal to red, what is the output? Minus 0.7. If the red true means answer is directly minus 0.7. False. False means again I'm going to divide the data by considering the age column. Age is greater than 37. Which one satisfies age greater than 37? This one. Age greater than 37. This one. And age greater than 37. Only these two. So these two records I have considered this side. Is that clear? And next one is age greater than 37, which is false. False is this one, this one, this one. These three. That is 0.3. This record of this is already red color, right? So we should not consider this one. 0.3, 0.3, 0.3. These three records. Is that clear? If you are having doubt, miss, I'm writing. This one is here. This record is here. This record is here. These three records we are considering in this leaf. Red is equal to this one. Directly I'm considering here. Now balance whatever these two records are there. These two records are here. Decision tree satisfied or not? Please check and tell me. Color is equal to red. True means 0.7. Color is equal to red means this is the only record. So the output is minus 0.7. I have written here. Age is greater than 37. Whichever the record satisfies, I am keeping here. Is that clear? Decision tree formed by considering this is the input data and this is the output data. By considering this one, I have created the decision tree. Not by considering the output variable. By considering the input variables, we have created the decision tree. Now, once the decision tree is calculated, now what we are going to do here, we are going to convert this one to, so in simple example, we are limiting to the number of leaves. Since we are having a small data set, here the number of leaf nodes is equal to 3 only we have got. But for example, if it is more than 32 means, we have to prune up to 32. So in practice, people often set the maximum number of leaves to between 8 to 32. So maximum number of leaf nodes should be 8 to 32. You can't go more than 32. Okay. So in the gradient boost, the pruning will be done based on the maximum number of leaf nodes. Right. Now here, whatever the values we are having, in this leaf node, one value is there. Okay, fine. But in this leaf node, I'm having 2 values. In this leaf node, I'm having the 3 values. Now what I'm going to do is, see, these 3 records has went here. These 2 records has went here. And this record has went here. That one also I have written in the PPT. Right. Now, what we have to do is, here we have to calculate the value of this one by considering sigma of residual divided by sigma of previous probability into 1 minus previous probability. So, for this leaf node, what is the initial probability? Guys, if you want, you can write in your notes, please. Take in the notes this data set. Write in the notes data set, please, first. Yeah. First, you write the data set. This is X1, X2, X3. First, you write only these 3 columns. First, you write X1 column, X2 column, X3 column. Up to here only you write. And output column, Y. Don't write this one. Don't write this one. Up to here you write in the notes. x1, x2, x3 and y. X1, x2 and x2, x3 and y. Only write only those three. Four columns and 6 records. Done? Done? Data set is done. Now, after doing that one, whatever the data set x1, x2, x3 completed and y also completed. Now you write in this one heading as initial probability. Initial probability, which is equal to e to the power of log of odds divided by 1 plus e to the power of log of odds. Okay, which is equal to e to the power of log of 4 by 2 for this data set divided by 1 plus e to the power of log of 4 by 2. And which is the answer is 0.7. And you write that 0.7, 0.7. For this record, initial probability is 0.7. For this initial probability is 0.7, 0.7, 0.7 and 0.7. Write the column name called as initial probability. And this is the leaf node. Leaf you have started with 0.7. Write down one leaf node. Down to this particular column, draw a leaf node stating 0.7. And initial probabilities are that one. Okay, column is completed. Now you create one more column. Residual of leaf node, right? Residual of leaf node. After the leaf node, whatever the residual was left, that is 1 minus, because this is 1, 1, 0, 0, 1, 1. So 1 minus 0.7, 0.3. 1 minus 0.7, 0.3. 0 minus 0.7 minus 0.3. 0 minus 0.7 minus 0.3. 1 minus 0.7, 0.3. Sorry, 0.7 minus 0.7. Okay, 0.7 minus 0.7. 1 minus 0.7 plus 0.3. Okay, you write like this. One more column create, that is called as residual after the leaf node. Okay, box is completed. Column, one more column is completed. Now in the nodes, you have to write create. Next step is you have to write in the nodes create decision tree number 1. Create the decision tree number 1 by using x1, x2, x3 and residuals of leaf node. Residuals of leaf node as the output. x1, x2, x3 as input and residuals of leaf node as output. Create the decision tree, first decision tree. Create your first decision tree. Okay, don't side to the box. Don't write side to the box, below to that only. Don't write side to that because we have to create one more column. Okay, don't write side to the box. Write down only. Create the decision tree 1 by using the x1, x2, x3 as input variables. And residual of leaf node as the output variable. Create the decision tree 1. That decision tree is this one right now in the nodes. This is the decision tree. Draw this one in your notes. X1, X2, X3, and these three of them are considered as input, and residual is considered as the output. And draw the decision tree 1. Create the decision tree 1 using this. How the decision tree was created? By using the Jenny value. Same to same. You have to calculate x1 value Jenny, x2 Jenny, x3 Jenny. Whichever the Jenny is high, you have to use the root node in that. And based on that only we have to create. Here the decision tree is not going to change. Again, it will calculate x1, x2, x3 separately Jenny only. Whichever the Jenny is high, that particular column will be considered as the root node. Is that clear? Done? Now, once the decision tree is also calculated, now you now write in the notes after decision tree. Now step 2. Step 2, you have to calculate the transform this leaf node. You have to transform each leaf node of the decision tree. Transform each leaf node of decision tree by using this formula. By using this formula. Write the formula. That is sigma of residual divided by sigma of previous probability into 1 minus previous probability. Transform each leaf node of the decision tree by using this one. Transform the data. Right? Done? Now, once this is calculated, once this is calculated, now how you are going next, you are going to calculate for this one. For minus 0.7, already you have written the initial this minus 0.7. For that record, what is the previous probability? What is the previous probability? 0.7 only, right? For every record, 0.7 is the initial probability. What is the previous probability is 0.7 is the previous probability. Now, for this, in this leaf node, whatever the values are there, you have to do the sum. Sum of the residuals means in this leaf node, whatever are there, everything you have to sum. In this, only one is there, that we are going to keep as it is. Divide by summation of, in this each value, what is the previous probability? For this previous probability is 0.7 into 1 minus 0.7, that is 0.3. You are having only one record. Now, for example, this one you consider. For this one, what do we have to do? 0.3 plus minus 0.7. So for this, what I'm going to, first let us complete this one. For this, what I'm going to do is minus 0.7. Whatever the 0.7 is there, that is total. Only one value only is there. Since one value only is there, minus 0.7 into divide by sigma of previous probability. Previous probability is 0.7. 0.7 into 1 minus 0.7. I have got 3.3. Now this value was converted to 3 minus 3.3. Okay. Completed. Now come to this node. What is the step you have written? Each leaf node of the decision tree, transform the data. In this leaf node, two values are there. Now how to transform? Summation. What is the formula? Summation. Summation means what is that? 0.3 plus minus 0.7. This is called as summation of residuals. Divide by, for this 0.3, what is the previous probability? 0.7 only, right? 0.7 into 1 minus 0.7. Plus, for this previous, what is the previous probability? Again, 0.7 into 1 minus 0.7. The same thing we are going to do. 0.3 plus minus of 0.7. That is, we are going to calculate the sum of this one divided by whatever the previous probability of this record and previous probability of this record is there, that we are going to substitute. For everything, the previous probability is same because that is the single leaf node is there, right? Initially, the single leaf node is there. So for everything, it is the same. And we are going to do this one, and we have got the -1 as the answer. Okay, after transforming, this is before transforming. After transforming, you have got as -3.3. This leaf node after transforming, you have got as -1. Now you are going to consider the third leaf node number 3. For this, what is the sum of the residuals? 0.3 plus 0.3 plus 0.3 divided by, for this record, what is the previous probability? 0.7 only. For this also 0.7 only. For this also 0.7 only, initial probabilities. So again, you are going to keep the same thing. Again, you are going to calculate. Now this value was transformed to 1.4. Now you keep that values. This -3.3, -1 and 1.4 you keep in the decision tree. In the decision tree, you write these values. -3.3, -1 and 1.4. Right? Clear, guys? This step is clear. Anyone wants repetition? It is clear? Denominator. So for example, once again, for this I am explaining. For this one, the sum of the residuals is 0.3 plus 0.3 plus 0.3. 0.3, which record? The previous probability is there, right? See that one, whatever the record of 0.3 is there, for that, what is the previous probability? 0.7 is the previous probability for this record. For that record only, you have to write into 1 minus 0.7. This is for this record. This record is completed. Second record. For this record, what is the previous probability? 0.7 is the previous probability. Because for initial one, everything is the same probability. From the second decision tree, the probabilities changes. For the initial one, everything is same. 1 minus 0.7. For the third record, plus third record, 0.7 into 1 minus 0.7. You have to add all of them because summation. We have to do the summation. So we have got the transform values like this, right? Now using these transform values, whatever the transform values we have got, now this is the original probability. Now for this, we are going to apply some learning rate. This is the learning rate. Now we have to add the learning rate. How much we are going to learn from this particular decision tree. Learning rate. So learning rate, I'm going to consider as 0.8. There is no fixed value. So we have to do the hyperparameter tuning for this one. So now hyperparameters. What are the hyperparameters? Is one of them is, we don't know what is learning rate. This is first hyperparameter. We don't know what is learning rate. So this is hyperparameter number 1. We don't know how many number of decision trees has to be pruned up to 32, 8 to 32. Maximum number of leaf nodes also we don't know exact value. We know only that it should be not more than 32. That is the only condition we know. Right? So these things we are going to use in the hyperparameters. Hyperparameter tuning we are going to identify, and we'll identify which is the best learning rate. Now using this learning rate, now once again recalculate for the original data. Now log of odds for the original data after decision tree 1. Initial probability you have completed, right? And you have calculated the residual of the initial leaf node. Now you write that one. Now you take in that only that table, whatever the table you have completed. That is x1, x2, x3, y, and you have written the initial probability. That is initial probability is leaf node. Your initial probability is nothing but leaf node. Next, residuals from this leaf node. Up to here you have completed. Now you are going to recalculate the probability. Now again you are going to calculate the probability based on the decision tree 1. This probability you are going to calculate based on the decision tree 1. And after this, you are going to calculate once again residuals of decision tree 1. process will be continued. Okay, let us continue. Now how we are going to calculate this one is, first we have to calculate the log of odds. Log of odds, how we are going to calculate? Just by applying for this data, for this record, 0.7 plus 0.8 into 1.4. Whatever the value you have got is log of odds. This one we have to keep in the e to the power of log of odds divided by 1 plus e to the power of log of odds. And we are going to calculate the p value. Now the p value was calculated 0.9. Initially it is 0.7. Now the probability has converted to 0.9. Similarly, for the second record, tell me for the second record now. You tell me for second record. For second record, initially it is 0.7. From the decision tree, this record belongs to which one? Yes. First, color is equal to red. True or false? False. False means this side. Age is greater than 37. True. True means which one? -1. So we have to have 0.8 into -1. That is nothing but 0.7 minus 0.8, which is minus 0.1. This is log of odd. Probability, e to the power of minus 0.1 divided by 1 plus e to the power of -1. This is the probability. The same thing I'm going to do. See, that is 0.7 into 0.8 into -1, which is minus 0.1. I'm going to substitute here and I will get the 0.5. That value I'm writing here. Clear? Next, record number 3. Now tell me the record number 3. Again, record number 3, log of odd. 0.7 plus 0.8 into, to which record this belongs to? This one. Color is equal to red, false. Here blue color is there, red, false. Age is greater than 37, true. True means this one. That is again -1. So this one. 0.7 minus 0.8, which is equal to minus 0.1. Again, probability is equal to 1 to the power of 1 e to the power of minus 0.1 divided by 1 plus e to the power of 0.1. Again, you get the 0.5. Same answer, whatever you have got earlier. Again, this one. Now you are calculating this one, this record, fourth record. Tell me log of odds for this. 0.7 plus 0.8 into color is equal to red. True means this one. That is minus 3.3. Value is 0.7 minus whatever the 3.3. Let us calculate. 3.3 into 0.8. 2.64. So 0.7 minus 2.64. That is minus 1.94. Now e to the power of minus 1.94 divided by 1 plus e to the power of minus 1.94. Let us calculate. E to the power of minus 1.94. E to the power of 1.94. Which is nothing but 0.778 divided by 1 plus 0.778. Nothing but divide by 1.778, which is 0.43. Right? So you are going to take the same value. So once again, please recalculate. So red color is, answer is minus 3.3. 3.3 into 0.8 is 2.64. 0.7 minus 2.64. Which is nothing but 1.94. Up to here it is okay. E to the power of minus 1. Otherwise we'll take like this. 1 divided by 1 plus e to the power of 5. Both are same only, right? Or sorry. 1 divided by 1 plus e to the power of minus 5. That is 1 divided by 1 plus e to the power of 1.94. Simple. Let us calculate this one. E to the power of 1.94 plus 1, whatever the answer we have got, plus 1, and 1 divided by 7.95. 1 divided by 7.95. 0.12. So which is 0.1. Right? So next we are going to calculate for this one. Similarly, we are going to calculate for this one. For each record, we are going to calculate the probabilities. How the probabilities are calculated? Based on the log of odds. First log of odds is this one. Now the log of odds is different. Now this is the predicted probability of decision tree 1. After combining the leaf node plus decision tree 1, this is the predicted probability. Now what is the error? Original data is 1, 1, 0, 0, 1, 1. Now you are going to calculate residual once again. 1 minus 0.9 minus, 0.1 plus 1, 0.1. 1 minus 0.5, 0.5. 0 minus 0.5 minus 0.5. 0 minus 0.1 minus 0.1. 1 minus 0.9, 0.1. 1 minus 0.9, 0.1. Calculated. Done. Second one is also completed. Now what we have to do? Decision tree 1 also completed. Now what is next step? We have to take x1, x2, x3 as the input variables. Now we have to create, by using this one as the output variable, once again create the new decision tree. Once again create the new decision tree by using this one. Again, by using these three versus this one, you create the one more time. Write in the notes. Create the decision tree 2. Decision tree 2 by considering the residuals after the decision tree 1. Okay. In the notes, first you write this one. Decision tree 1 probability residuals. After writing these two, then you come to the next step. First, please write this one. This column. Add this column for you. The previous table, add this column. Add this column. What is this column is? Probability based on the leaf node plus decision tree 1. This is the residual. This is the residual of decision tree 1. Leaf node plus decision tree 1. Combining we have got. This is the residual. Now, next step is create the decision tree 2 by using x1, x2, x3 as input and residual of decision tree 1 as output. By considering this one as the input and this one as the output, now you are going to create the decision tree 2. Means indirectly you are focusing on the residuals. You are trying to reduce the residuals to 0. Means you are trying to reduce the error to 0. Instead of directly working on the answer, you are indirectly working with respect to error to be 0. Error is 0 means automatically accuracy is high. One way of doing is increasing the accuracy. One way is reducing the error. Both are same at the end. Now you have created one more time decision tree. Now, once the decision tree is calculated, now what we have to do? We have to transform. Again, we have to transform each leaf node. How we have to transform? Again, we have to apply the formula. Now, for this leaf node, can you tell me for this leaf node, what is that one? We have to apply the formula. Minus 0.5 divided by, what is the previous probability of this record? What is the previous probability? Earlier probability. What is the earlier probability? Just we are going to substitute that earlier probability, that is previous probability is 0.5 into 1 minus 0.5. For this record, this is the value, numerator value. This is the previous probability. Okay. Now, we have got the transform value as 2. Now, next comes to this one. For this data, this one belongs to this one. For this one, tell me transform value, that is minus 0.5 divided by, what is the previous probability? 0.5 into 1 minus 0.5. Now this, everything are not same, right? Previous probabilities are not same, right? Each one are different. Now again, you are going to calculate accordingly. That is minus 0.5 divided by 0.5 into 1 minus 0.5. And you are transforming the value to minus 2. Now for this data set, for this third leaf node, For the leaf node 3, okay, for this leaf node, what is the sum of the residuals? 0.1 plus minus 0.1 plus 0.1 plus 0.1. That is, numerator is 0.2 divided by previous probability of first record. 0.9 into 1 minus 0.9 plus minus this is 0.1 into 1 minus 0.1 plus for this record 0.9 into 1 minus 0.9 plus for this record 0.9 into 1 minus 0.9. Like this we are going to calculate. That is values divided by like 4 values. We are going to keep the 4 values. 0.9 into 1 minus 0.9 is 0.9 into 0.1, which is 0.09. 0.1 into 1 minus 0.1 is 0.1 into 0.9. 1 into 0.1 into 0.9 is 0.09. 0.9 into 0.1. 0.9 into 0.1. 0.09. 0.9 into 0.1. 0.09. And finally, we have transformed the data like this, 0.6. After transforming, what is the next step we have to do? What is the next step? Again, we have to start the predicting the probability. Again, predict the probabilities. Now combine everything. This one, and this one. Now, first record. For first record, what is the first record? So, what is the first record? First record is yes, 12, blue, and okay. These are the 3 input, x1, x2, x3. These are the 3 inputs. For these 3 inputs, what is the predicted probability? This is using the first one, second one. 2 decision trees are there. Now tell me for this record, what is the log of odds? Log of odds is equal to 0.7 in plus 0.8 into first. From this decision tree, what you will get? Color is equal to blue, false. Age is greater than 37. Again, this is also false. 1.4, that is 1.4. Plus, again 0.8 into, for this record from this data set, age is less than 66, true. Age is greater than 37, false. Miss this one, that is 0.6. So, log of odd is equal to 0.7 plus whatever the value you have got. This is log of odds. Again, you are going to calculate the predicted probability. Once you calculate the predicted probability, again you will calculate the residual. After calculating the residual, again decision tree number 3. Cycle will continue. Till how much the cycle will continue is till the error you get the 0. Till you get the error as 0. Perfect answer you get, till that it is going to continue. Now, for this unknown data, completely a new data, yes, 25 green. Assume that tree gradient boost was stopped here only. I have given the number of trees is equal to only 2. Estimators is equal to 2. That it has stopped here only. For this data set, can anyone tell me the answer? How to calculate? What is the first step we have to do? Log of odds. What is log of odds? First, 0.7 plus 0.8 into here, color is equal to red, false. Age is greater than 37, false. False means 1.4. 0.8 into age is less than 66, true or false? True. Age is greater than 37, false. 0.6. Now, 0.7 plus 0.8 into 1.4. 0.8 into 1.4, 1.12 plus 0.8 plus 0.8 into 0.6, which is 0.48. 0.48. That is equal to 0.7 plus 1.12 plus 0.48, which is 2.3. This is log of odds. Using the log of odds, what we have to predict? Probability. e to the power of 2.3 divided by 1 plus e to the power of 2.3. So let us open e to the power of 2.3, which is 9.97 divided by 10.97418, and I have got 0.9 as the probability. Since 0.9 is greater than 1, so that person is going to love the movie. Yes, answer is yes. In this way, we are going to predict for the new data. So the same thing will be there here. 0.7 plus 0.8 into 1.4 plus 0.8 into 0.6, which is 2.3. And we are going to calculate this one by substituting in the probability e to the power of 2.3 divided by 1 plus e to the power of 2.3, which is equal to 0.9. So the answer is, since the value is greater than 0.5, answer is yes. In this way, it is going to predict the answer. That is the way the gradient boost works. Here I have shown you with n estimators is equal to 2, means by considering only 2 decision trees. Okay. Default, it is going to continue till the error is 0. Till the predicted values and residuals becomes as 0, till that it is going to continue. Till the residuals becomes as 0, the sum of the residuals becomes 0, it is going to continue. And it will continue. Or either trees should be completed. For example, after 20 trees, I have given up to 20 only. But after 20 trees, it has not completed. It will stop there only. Whatever the value or error should be 0, any one. It is clear? The data set I have taken, step-by-step calculation I have shown, and complete gradient boost. Any questions? If you have any questions, you can ask me. Type your questions. Now, decision tree, each decision tree, how it is selected means, for that data set, it is going to calculate the Gini index. How the Gini index will be calculated? For example, one of the student is asking, sir, in the decision tree 1, we are taking this color column. Okay, column color is selected. Okay, why red only it is selected? Within the Gini index, how to calculate the Gini index? For each category we are calculating, and after that weighted Gini only we are calculating, right? Do you remember the Gini index or forgot? How to calculate the Gini impurity? For each category we will calculate the Gini impurity, and weighted impurity also will add. And based on that only this color or blue, whether the blue or everything will be selected. Whether Y color is equal to red only has taken, why you can't take color is equal to green. That everything is decided based on the decision tree. Here nothing is special. That conditions are selected in the decision tree. How the decision tree works, that it is going to work. The only thing is, it is going to combine everything. It is combining each of them. It is not going to work on the individual. It is combining. Right? Here, the question mark is learning rate. How this learning rate of 0.8 you have selected? Don't select 0.8. Select only 0.1. Do the calculation. And calculate this train accuracy is complete. Train accuracy, test accuracy, 2 are there, right? First you take with only 0.1 and calculate the test accuracy. Test accuracy means predicted value, original value. 2 values will be there, right? First you go with 0.1 and calculate the test accuracy. Write that value. Go with 0.2. Calculate the test accuracy. Write that value. 0.3. Test accuracy. 0.4. Test accuracy. 0.5. Test accuracy. 0.6. Test accuracy. 0.7. Test accuracy. 0.8. Test accuracy. 0.9. Test accuracy. 1. The maximum is 1. Minimum value is 0. 0 to 1. It can't cross more than 1. It can't be less than 0. So we are going to try for different learning rates and identify which is the best learning rate. That is the grid set CV. So in the grid set CV, we are going to give the learning rates from 0, 0.1, 0.2, 0.3, like this. We'll give all the values up to 1. And we'll see for everything it is going to apply. For each and everything it is going to take and it is going to apply. Once it applies for everything, it will only identify which is the best one, which is the best learning rate. Learning rate is not a fixed value. Here I have shown you for calculation purpose, any one value we have to take, right? For that purpose, I have taken 0.8. 0.8 is not the fixed value. It might take, first you have to try with 0.1, 0.2, 0.3. Everything you have to calculate. Is that clear? For example, this is the original, this is the test data. Okay. In the test data means X train, Y train, we know. You know X test, Y test also, X test and Y test, right? In the X test also we have the X1, X2, X3 and Y also will have. Original data also will have. Now how we are assume this original answer is yes. Assume it is original answer is yes. Now you have tried with 0.1. First you have kept here the learning rate as 0.1. 0.1 and 0.1. You have got the wrong answer. You'll get the answer as no. You'll change to 0.2. You'll get again no. 0.3. Yes. Now you have got yes. Oh, minimum 0.3 is required, it seems. We'll understand like that. Now assume that this is answer is yes, already yes. You predicted also this time yes. But one more, we are having this one. The answer is no. By using the 0.3, we have got the answer as yes. Output is yes. Predicted answer is X. Now, one is correct, one is wrong means what is the test accuracy? 50% is the test accuracy. Now we are going to change to 0.4. Again, the same 50% test accuracy. 0.5, 50% test accuracy. 0.6, 50% test accuracy. We are going to change to 0.6. Assume it has went to 0.6. Now you got the answer as this one has changed to no. Means this one correct, this one is correct. 100% accuracy. When you have got the 100% accuracy, when you change that learning rate to 0.6, you have got that one. So 0.6 is the best one for the given data. Like that we are going to calculate. That is the grid search CV. Grid search CV, it will apply for each of them and it will calculate every time the test accuracy and it will identify the which is the best parameter. Learning rate is not the fixed value. The only thing is the learning rate, whatever the learning rate is there, learning rate should be between 0 to plus 1. How much percentage? This should be from 0 to 1 only. It can't be negative value. It should be only the positive value. It should be only the positive value. That too, it should be from 0 to 1 only. Okay, where 0 is not included, 1 is also not included. Both are not included. The maximum value of learning rate is 0.999999999, but 1 is not included. 1 should not be included, right? Similarly, second point is all the learning rate should be the same. For first decision tree, one learning rate. For second decision tree, different learning rate. You can't consider. That is not possible. For every decision tree, same learning rate will be there. Learning rate will be constant for all the decision trees. Correct learning rate will be identified by using the hyperparameter tuning. Is that clear? So whether the given data is overfitted or underfitted, first we have to give the data and we have to calculate the train accuracy and test accuracy. Once we calculate the train accuracy, test accuracy, then only we can tell whether it is a overfitted or underfitted. Is that clear? So tomorrow we are going to work on the next one called as XGBoost. XG is 5 minutes only. But if I say now means you will confuse. So tomorrow we'll discuss. Just 5 minutes, 5 or 10 minutes max. If you understand the gradient boost clearly, that is 5 minutes. Right? So tomorrow we are going to continue and we'll see the coding part of ADA boost, gradient boost and XGBoost at a time. On the single data set, we'll apply all the 3 algorithms.